Welcome to all of you in Sankalpa Education Pratham classes. I am Sachin Patil, delivered lecture series on derivative. Right now we are going with the implicit functions are here, and in implicit function we know that the x and y are not differentiated from each other, and therefore we can carry out the implicit function by using a procedure, and inside this procedure we know that about the derivative, taken derivative of each terms inside the implicit function, and then if there is any y, then take the derivative of y is dy by dx. If there is any y raised to n, then derivative of y raised to n is n into y raised to n minus 1 into dy by dx, and then we collect the dy by dx terms on the left hand side, then taking the dy by dx as a common and remaining terms are transferred to the right hand side. You will get the result, or you will get the derivative of that implicit function. Right now we are going with the consideration this procedure related to that implicit function derivative, which is taken inside the previous lecture. If you not attended the previous lecture, then you can attend the previous lecture, then come to the example lecture related to implicit function. Right now we have to going with one derivative or one implicit function is here, and therefore how to calculate the derivative of that function is as follow. We have x square plus e raised to xy is equal to y square plus log x plus y is here, and right now we have to take the derivative of this, take the derivative of that implicit function because here x and y are not separated from each other, and therefore taking derivative with respect to x is here, taking derivative with respect to x is here, and therefore d dx of x square plus d dx of e raised to xy is equal to d dx of y square plus d dx of x plus y is taken here. That means we can perform the derivative of each term related to that implicit function by using that one. Then derivative x square, having the derivative is nothing but a 2x plus e raised to xy. That means this function is nothing but a composite function, and we know that the derivative of e raised to x is e raised to x. Therefore, first of all, we are taking the derivative of e raised to xy is nothing but a e raised to xy into d dx of x into y. That means we have to perform the derivative of that index is multiplied here and is equal to derivative of y square. Y square having the derivative is nothing but a 2y into dy by dx, because according to our consideration related to that one is nothing but a d dx of y raised to n is equal to n into y raised to n minus 1 into dy by dx is here. And by using this you can follow the derivative of y square is nothing but 2y into dy by dx is here. And right now we are going with the derivative of here we have to get the consideration of log x plus y is here, and therefore first of all we have to take the derivative of log. That means plus derivative of this is nothing but x plus y. Log x having the derivative 1 divided by x, that means log of x plus y having the derivative 1 divided by x plus y into d dx of x plus y is here, because it is a composite function, and then you have to get the 2x plus e raised to xy into, here a derivative is taken by using a multiplication function. Multiplication of two functions are there, then first function put it as it is, and derivative of y is nothing but dy by dx, plus second function put it as it is, and derivative of x is nothing but 1 is here. Then we have to getting the 2y into dy by dx plus 1 divided by x plus y into derivative of x plus y is nothing but 1 plus dy by dx is here. 1 plus dy by dx is here. and then you have to going with the consideration of this e raised to xy is multiply inside the bracket, and you will get the 2x plus x into e raised to xy into dy by dx plus y into this one is nothing but a y into e raised to xy is equal to 2y into dy by dx plus 1 divided by xy is multiplied inside the bracket, that means you will get the 1 plus x plus 1 divided by x plus y into dy by dx is here, and then we collect the dy by dx terms to the left hand side. That means this term is containing the dy by dx, this term containing the dy by dx, and this term containing the dy by dx, and therefore those terms are taken to the left hand side is here, and by using that one you have to get the consideration like that one, x into e raised to xy into dy by dx. This first term is present in the left hand side taken as it is, then this term is on the right hand side, then it is a transfer to the left hand side, therefore you will get the minus 2y into dy by dx is here, minus 2y into dy by dx is here. This term also here plus and containing the dy by dx, therefore it is a transfer to the left hand side, that means you will get the minus 1 divided by xy into dy by dx is equal to the term containing the without containing the divided by dx is nothing but this one term is here, and therefore it is present as it is 1 plus x 1 divided by x plus y. Then this term is transferred to the left hand side, and this term also this term transferred to the right hand side, and this term also transferred to the right hand side. You will get the consideration of minus 2x minus y into e raised to xy. And right now from this you can take the dy by dx as a common, dy by dx common, inside the bracket you will get the x e raised to xy minus 2y minus 1 divided by xy inside the bracket, and then you can follow the consideration same as it is that of the clearance related to that one is nothing but a 1 minus 2x minus y into e raised to xy 1 divided by x plus y is here, and first of all we have to make the denominator same by multiplying x plus y to each term, and therefore you will get the dy by dx inside the bracket. This into this is nothing but x into x plus y into e raised to xy minus 2y into x plus y minus 1, and whole divided by x plus y is here, x plus y is here. Similarly you can make the denominator same here, and you will get the consideration 1 minus 2x into x plus y minus y into x plus y into e raised to xy is here, and whole divided by x plus y is here. Now this term is transferred to the right hand side. At that time x plus y cancel to each other, and you will get the dy by dx is equal to 1 minus 2x inside the bracket 2x plus y minus y into x plus y into e raised to xy whole divided by x into x plus y e raised to xy minus 2y inside the bracket x plus y minus 1 is here, and this is your derivative related to that function, and you will get the final result of that derivative dy by dx by of implicit function here. We now going with the next example related to that one. Now we are going with the next example related to implicit function. One is if x raised to m y raised to n is equal to x plus y raised to m plus n, then prove that dy by dx is equal to y divided by x is here. Then first of all we have to take the consideration of we have x raised to m, y raised to n is equal to x plus y raised to m plus n. Now taking the log on both sides, taking log on both sides. both side. Log of x raised to m y raised to n is equal to log of x plus y raised to m plus n is here. That means here multiplication of these two terms, and therefore we have to take the separate log and taking the addition of this one, and that means we will get the log of x raised to m plus log of y raised to n is here. And here m raised to n is in the index of that x plus y, and therefore it is a multiply to the log, and therefore m plus n into log of x plus y is here. Similarly, m is in index of that x, and here we have to take the log, therefore m is multiplied here, and therefore m into log x raised to m plus n into log y, sorry, here only x is there, and you will get the m plus n into log x plus y is here. That means first of all we have to follow the rule of logarithmic. First of all we have to take the logarithmic differentiation, and first of all we have to take the log, and then we have to carry out the implicit derivatives related to that one, and then take derivative on both side with respect to x is here, and here m is a constant, and therefore m into d dx of log x plus n into d dx of log y is equal to m plus n is again a constant into d dx of x plus y is here. Then derivative of this log x is nothing but 1 divided by x. Therefore, you will get the m into 1 divided by x is here plus n into log y having derivative 1 divided by y into dy by dx, which is taken inside the logarithmic differentiation, and according to that one, log y having the derivative 1 divided by y into dy by dx is here. Then we have to carry out the consideration here. Sorry, once again one mistake is there. Log x plus y is there, and m plus n is constant, taking as it is, into derivative of log. First of all we have to take the derivative of log is nothing but 1 divided by x plus y into derivative of x plus y is nothing but x having the derivative 1 and y having the derivative dy by dx is here. Then we simplify it by using the consideration m divided by x plus n divided by y into dy by dx is equal to m plus n divided by x plus y into 1. That means 1 plus m plus n divided by x plus y into dy by dx. dy by dx is here. Right now we know that the consideration of we collect the dy by dx term to the left hand side, and then we follow then we carried out the dy by dx as a common, and then we transfer the remaining term to the other right hand side is here. Then this term is containing dy by dx, then it is remain as it is, but this term containing dy by dx which is present on the right hand side, first of all we transfer it to the left hand side. Then you will get the consideration of here, and follow the consideration by using the n divided by y into dy by dx minus this term is nothing but n plus n divided by x plus y is here into dy by dx is equal to, the remaining term is here is nothing but m plus n divided by x plus y, and this term does not containing the dy by dx, therefore it is a transfer to the right hand side, and therefore you will get the minus m divided by x is here. Minus m divided by x is here. Now we carry out the dy by dx common here, and therefore dy by dx inside the bracket n divided by y, minus m plus n divided by x plus y into is equal to here m plus n divided by x plus y into minus m divided by x is here. Now we make the denominator same here by using the multiplication, cross multiplication. You will get the consideration of dy by dx inside the bracket x plus y into n, that means n into x plus y minus y into m plus n divided by y into x plus y is here, and it is equal to m plus x into m plus n minus m into x plus y and whole divided by x into x plus y is here. Okay, then we multiply this n and y inside the bracket and you will get the consideration of dy by dx inside the bracket nx plus ny minus, because this minus is taken, my minus ny and whole divided by y into x plus y is here. Y into x plus y is here. Similarly, we multiply this x inside the bracket, you will get the mx plus mx minus my and whole divided by once again x into x plus y is here. Then ny is cancelled to ny and therefore you will get the dy by dx inside the bracket nx minus my divided by y into complete is equal to once again cancel to each other, therefore once again nx minus my divided by x into x plus y is remain here. Then this term is transferred to the right hand side, you will get the consideration of dy by dx is equal to nx minus my divided by x into x plus y into y into x plus y divided by nx minus my is here, and nx minus my is cancelled to each other and you will get the x minus x plus y is cancelled to each other. You will get a y divided by x is here and dy by dx is equal to y divided by x, and this is your proof related to that one, and you will get the consideration of this one. If you like that video, please subscribe my channel and press on bell icon to get the next notification related to that lecture series. Thank you.